Hey, good day to you all. Welcome to another edition of Weather Academy. I'm meteorologist Tom DeVecchio, and we do this every Wednesday, keeping things going here as many of you are still doing some in-home teaching. And what I have here, very simple. I'm like, boy, I must be really thirsty. Okay, I have these very complicated props here to talk about something that can get a little bit confusing, a weather topic, and that is relative humidity. Now, moisture in general is so important in weather. It's, as you might guess, one of the most important aspects of moisture is how much cloud cover we get. Kind of like the image behind me here. You see some of the clouds there. Anything that you see clouds in that image, that means there's moisture in the air that has condensed. So the relative humidity is a measure of how saturated the air must be in order for us to get clouds to form. Now, relative humidity has to be 100% in order for clouds to form. And relative humidity, by definition, is how saturated the air is at any given temperature. And that part is important. Relative humidity changes based on the temperature of the air. And that's where it gets a little bit confusing. So generally speaking, and a lot of times, when I think about this, my old meteorology professors would not be happy with me if I were to talk about relative humidity as a sponge, or how well air holds moisture based on a sponge. But it's the best way that we can describe it. But in this case, since I don't want to anger my former professors, I'm going to use some different props to represent how relative humidity occurs here. So the colder the air is, the less ability it has to hold moisture. So temperature 30-degree air cannot hold as much moisture as 70-degree air. So what I have here, I have some water here in this coffee pitcher. Wouldn't mind having a little coffee here along with it. And I have a cup here, and I have a small glass and a larger vase. Now, what I have here, the glasses are representative of air at a different temperature. So let's say that the glass here represents air with a temperature of 30 degrees, while the vase here represents air with a temperature of 70 degrees. So this is the warmer air, this is the cooler air. Now, because warmer air can hold more moisture, has the capacity to hold more moisture, this is a bigger item than the smaller glass. And if I had, I could go down the line. I could have an even smaller glass, say for 10-degree air, and I could have a larger vase for 90-degree air, let's say. But I think you get the picture. 30-degree air, 70-degree air, and again, these are just examples. So what I'm going to do, I have this coffee cup to make sure I put the same amount of water in each vessel here. So let's see if I can do this without spilling it. So we'll put a cup of water, a coffee cup of water here in the glass. Yeah, a little spillage, not too bad. And I'm going to put the same amount of water into the vase. Now, both vessels, the glass and the vase, have an equal amount of water. So the amount of moisture, the amount of total moisture in each is the same. 1 cup of water in here, 1 cup of water in here. But if you notice, the glass is fuller than the vase. So therefore, if this water represented the water vapor that's in the air, the relative humidity of this glass, this looks like about 3/4 full. So the relative humidity of the air at 30 degrees is, roughly 75%. But in the vase, with the same amount of moisture, but it's only probably about, not even barely 1/4 full. So the relative humidity of the vase is 25%. So which one has more moisture? Well, the answer is neither, because they both have the same amount of moisture. But which one is more saturated or closer to saturation? That would be the 30-degree air, because it has more water compared to what it's able to hold compared to the larger vessel. So what does that mean for us from a practical standpoint? Relative humidity, if anything else, can help us determine when clouds will form, because clouds can form when the relative humidity is 100%. So if we were to put a little more water in here until it's totally full, now we have a relative humidity of 100%. So once the air gets to 100% saturation, that is when we have a cloud forming. That's when the air can no longer hold any more water vapor, so anything more that comes in would condense and form clouds. So how do we get the clouds to form? Well, two ways. One was the way I just showed you, is the pouring of more water, putting more water vapor into the air. Maybe it's evaporated from other sources or brought in from other sources. The other way we can get the relative humidity to go up is to cool the air. And how would that happen? Well, let's see, can I put this back in? I'm going to do this here. And I should have got a smaller glass. I thought I might have one here, but I guess I don't. But the fact is, if this were a smaller glass with the same amount of water, well then that too would help saturate the air and get the relative humidity to 100%. So the goal of Mother Nature here to get clouds is to get the relative humidity to 100%. Now this one, it would take a lot more water vapor to get this to saturation. But what would happen if we did manage to get the water vapor totally saturated? Oh, just almost gets to the top. Now it's to the top. So this has a lot more water in it. So what does that mean? That means that if we did manage to get the relative humidity of the larger vessel to 100%, then this would have a much better chance of giving us more rainfall, because there's a lot more water than in the smaller vessel if it were saturated. So 100% at 30 degrees wouldn't give us as much moisture, it wouldn't give us as much rain or snow as the 70-degree vessel. And when you think about it in practical terms, when do we get most of our heavy rain? Do we get it in the wintertime when it's chilly? No, we get it in the summertime when we have warmer temperatures, more water holding capacity, and better chances of getting some heavier rainfall. On the other side of the coin, why is wintertime cloudier than the summertime? Because it's much easier to saturate the air when you have colder temperatures. So clouds form more quickly in the wintertime than it does in the summertime, but the amount of precipitation is generally less in the wintertime than it is in the summertime, because there's not as much moisture. And you say, well, wait a minute, Tom, we have, 2 feet of snow. Isn't that a lot of moisture? Well, it tends to be, but keep in mind, snowflakes are much less dense than raindrops, okay? Oftentimes you hear 10 inches of snow to 1 inch of rain. So it's not unusual for us to get an inch of rain, in the summertime. 10 inches of snow, it does happen, but not often. Because snowflakes are less dense, and it's also because they're shaped six-sided, they can't stack as easily. So, they do stack easily, but there are a lot of holes in a pack of snow that you wouldn't get when you have water. So yes, you're saying, gee, we get a lot of snow here, but snow has a lot lower moisture content than rain does, and that's why the wintertime tends to get cloudier than the summertime. So there you have it. That's how we utilize relative humidity and how we use it in a practical sense. And hopefully it helps clear things up for you on how relative humidity forms and why the numbers change not only from day to day, but often from hour to hour. Usually the relative humidity is highest in the morning when our temperature is coolest, okay? And then as temperatures get warmer through the day, the relative humidity tends to drop because the capacity is increased, but the amount of moisture usually stays the same from day to day. So there you have it, relative humidity. We use it a lot in weather. Very important concept in trying to determine just how cloudy it will get and just how much rain we will get in a particular day. Thank you so much for joining us. Take care, and we'll have more exciting topics again over the next several weeks.